All right, so I am going to record this session for today, okay? Today is Monday, February the 7th. Please make sure that you put your first and last name at the top of your packet if you haven't done so already. Today's date, again, is the 7th. This is week 3. This is the wrong one. Oh, well, I put the wrong week at the top, but it's this week. It is week 3. All right, I just realized that I didn't change the week, but that's okay. All right, so these are the assignments that are due. Okay, the assignments that are due. You have your warm up. This is due Friday. You have your homework. It's due Friday. We have a quiz on Friday also. Please make sure I may assign some word problems on exponential functions depending on how far we get. So that's why I'm putting a star right here, that it could be some word problems that are due. Okay. All right. The tutoring this week is Wednesday at 3 p.m. It's virtual. Do not forget about the tutoring this week. Wednesday, virtual. Today, we're going to work on our warm up. We've already worked on our warm up. I'm going to go over it. Then we're going to paste the vocabulary words some vocabulary words in our notebook. And then we're going to work on exponential functions. A lot of notes that we have today. Exponential function booklet. Okay. All right. Our homework for tonight, I'm going to make a homework help video. So please make sure that you also watch the help video if you need help with the homework. Any questions, comments, or concerns about what's due this week or what we're doing today? Okay, so let's look at the warm up. Actually, let's write down our work in our planner. Sorry about that, y'all. So we're doing a new page in our planner. This is going to be at the top where it says month. Please do February 7th through the 11th. And this is Q3W3. This is Q3W3. And we're going to be in blue. Okay. Your work is going to be in blue. The dates are on our packets. It's from the 7th through the 11th. So Monday is the 7th. Tuesday is the 8th. Where's your planner? Wednesday is the 9th. Thursday is the 10th. Friday is the 11th. And guys, the reason why I'm making this super duper important, I know you're like, why is she making this so important? Because when you get in a ritual, when you get in the habit of doing something, it helps you with your discipline, which in turn helps you become more successful. Okay? People that are flaky, one minute they're doing this, the next minute they're doing that, okay, and they're all over the place. It's hard for them to get to the final destination because they get off course so much. But if you are more focused and you are disciplined, that's going to make you a stronger student, and it's going to mean that you're going to have a higher success rate, okay? Because you are more disciplined. You're not flaky. You're not off and on. Disciplined people that repeatedly do the same, practice the same good principles every day are most likely going to be more successful than people that don't. It's like every other day they do their homework, or every other day they do this, or maybe every other day they practice. They're not going to be as strong as somebody that practices every day. And that's with anything. That's with sports. That's with math. That's with reading. That's with everything. The more you practice, the stronger you become at something. Okay. So super duper important that we establish some good tools for success. All right. So in blue, we got math 1 homework. We need to work on our already. Okay. And that's a given every day. Please, if we don't work on it Monday, we need to do something Tuesday or Wednesday. We already know that the already project is due February the 18th. So you need to pace yourself. Believe it or not, we're already in week 3. That's crazy because it feels like the quarter started last week, but it didn't. So we're already 3 weeks in. Okay. So I say that to say time is going by so fast. So please don't wait to the last minute If you haven't already started with already, you need to get started, okay? Because that 18th will be here before you know it. Our virtual tutoring's in blue. That's a Wednesday at 3 p.m. If you cannot make this time, I say this over and over again, you need to text Ms. Reyes and say, can I get another time? Can we work out another time or something, okay? And commit to that time. If you can't make that time, just text me and let me know so I'm not waiting on you, okay? So just let me know that you're not coming, okay? Your, because stuff happens. I mean, it just does. Everybody knows that. Assignments are due Friday. So you're in blue. Math 1 assignments are due, and you have your Math 1 quiz. And it's on everything that we cover this week. Are there any questions, comments, or concerns? If you didn't finish the quiz from Friday, you need to make sure that you go back and complete that quiz. Remember, you always have 2 chances. Okay? After your 2 chances, it's just going to take the highest score. Questions? Are y'all okay? All right. Anybody still copying? Okay, good deal. All right, so let's go over the warm-up. We should be finished with the warm-up. So let's check it, make sure it's right. Okay, so we're doing laws of exponents. Anybody need me to pause? Is everybody okay? Hannah, you good, baby? You good? Okay. All right, so let's divide. We got a negative divided by a negative. What's a negative divided by a negative? This is a positive. So we got 48. Let's do the numbers first. A negative 48 divided by a negative 8 is going to be a positive what? 6. So we got 6 so far. So remember, now we're dealing with the variables. When you have like bases, you can subtract the exponents when you're dividing. So this is going to be C. This is 2 exponent here. This is 1 exponent here. So this is 2 minus 1. The exponent on top goes first minus the exponent that's on the bottom. This is D to the 4th and D to the 1st. So this is going to be D4 minus 1. 4 is on top. That goes first. 1 is on the bottom. That goes second. So then our final answer here is going to be 6C to the what power? First power, or we can just leave it as C, right? D to the what power? Third. Raise your hand if you got that right. Okay, great job. Okay. The second problem. A construction company charges $15 an hour for debris removal. It says plus a one-time fee to use the trash dumpster. The total, we got a total here, the total for 9 hours is $195. We're going to write an equation. So they gave us the slope, how much it costs per hour. So that's M. This is a linear equation. So it's 15 per hour. Okay, and Ms. Reyes knows it's a linear equation because it's the same amount every single hour. Okay, so you're adding the same amount for every single hour. All right, so they give you basically a point. This is my hours and this is my total amount. So hours is X. You see how they tell you hours is X? Hours is 9. That's X. And the total amount, you see the total fee is Y. And the total fee for 9 hours is $195. This is Y. So in order to write a linear equation, the information that they did not give you is B. So you have to figure out what B is. So does anybody remember how to find B? Yes.
Y equals mx plus b.
Very good. Y equals mx plus b. Great job. Okay. So now I am going to use the information that's given and substitute it into the slope-intercept form to solve for B. Okay, so what am I going to put in the place of Y?
195.
195 equals, what am I going to put in the place of M?
15.
We got 15 times, what's my X? 9, and we have plus B, which is what we're trying to find. Okay, which is what we're trying to find. So now let's simplify. What's 15 times 9?
135.
135. So we got 135 plus B. Now how do we get B by itself?
We subtract 135 on both sides.
We subtract 135 from both sides. When we subtract 135 from both sides, that gives me B is equal to what number? 60. So now I have an M and I have a B. How do I write this as a linear equation? Very good. Any questions about that? I'll pause for the calls to give you a chance to correct your mistakes, okay? All right. Remember, there's a homework help video that I'm going to send out for the homework tonight. Okay, I'm not going to do all of them, but I am going to show you how to do them. Okay. So please watch the video this evening if you need assistance. Okay, so now let's look at our interactive notebook. We already paced down the pages. We paced down the book. Well, no, we didn't, did we? Did we paste this down, right? All right, so we need to do that. So we paced down number 12, which is the intro to Unit 3. Now we need to paste down this foldable here. This is going to be, and I'll pause to give you guys a chance to catch up. This is going to be page 13. And I'm going to go ahead and write the title and then pause. This is page 13. This is Exponential Growth Foldable. Exponential Growth, and it's the foldable. Okay? And don't forget, it looks like this. And I wanted you to graph the equations on the bottom, example 5 and example 6. We went through those, and the only thing that was left to do there is to graph them. All right, and let me pause here. We're going to paste down these vocabulary words. The title of this page, this is Q3, quarter 3. We got page, I forgot just that quickly, it's page 14. And my E is flying away. This is key vocab words. And this is going to be for Unit 3. We're going to paste this down. And look, I'm going to fold this, and the words are upside down here. But that's okay. We're going to put glue on this blank side right here. So when you fold it in half, put glue right here and paste it down just like this, okay? 2 words that are upside down, but I had already ran it through, and I wasn't going to throw away all that paper and start again. That's a lot of paper to waste. So that's okay. 2 of the words are upside down. We can live with that. What you need, baby? You didn't get one? No. Oh, go ahead. Okay. Everybody got it? Okay. I didn't see it on your desk. So let's glue this down. Come on, Caleb, glue this down, baby. What's wrong? You're not in a good mood? Are you upset about something? Okay. Oh, that's the bathroom. Okay, that's right. All right, so we're going to, thank you, baby. Thank you. So we are going to go. We're going to pause for the call so we can go to the restroom and then come back. All right, good people. So we have that pasted in. This next page, page 15, actually, I'm just going to keep that blank. We won't worry about that just now. We're going to push that to the side. I gave you a little booklet. We're going to work out of the booklet. Please put your name at the top. Please put your name at the top of the booklet, okay? Exponential functions. Yes, I do. If you all could please pass the glue up to the front. And then the first person in the row, please put the glue stick back on the table. Thank you. Excuse me. All right. So first thing that we're going to do is we're going to talk about the difference between linear and nonlinear, okay? Linear and nonlinear. All right. So with a linear function, by definition, is going to be equations that graph straight lines. Excuse me. Equations, linear functions or equations are equations that graph straight lines. Equations that graph straight lines. Please write this down. Equations that graph straight lines. Now we're going to draw what that looks like. We're going to do 4 examples. So we're going to draw 4 coordinate planes. 4 little small coordinate planes, right? And we've done this like a lot of times. You'll see this in our notebook a bunch of times because we've done it so many times. So we have lines that go up. They have a positive slope. We have lines that go down. They have a negative slope. These are all linear now. We have lines that are flat. They have 0 slope. And we have lines that are vertical. They have undefined slope. So we have straight lines that have positive slopes, straight lines that have negative slopes, straight lines that have 0 slopes, and straight lines that have undefined slopes. Those are all examples of linear equations. Any questions about that? Okay, good deal. Exponential functions or equations are equations that graph curved lines. Equations that graph curved lines. Semicolon. They're going to grow by a common ratio. Grow by a common ratio. We already talked about the word common ratio. Or percent. Percent increase, decrease. Common ratio greater than 1, less than 1. So it's either going to be, it's going to grow, growth or decay. So either an exponential function is going to have a curved line going up or a curved line going down. So it's either going to have some growth or it's going to be a decay. It's 2 types of exponential functions. If it's a growth, then the curved line is going up. Okay? If it's decay, it's a curved line going down. This is sometimes where the vocabulary word that you see, asymptote, that's where the line approaches 0. It approaches 0 on the y-axis, but it never hits 0. Okay, that's the asymptote, where it approaches 0, and then most of the time that happens in word problems, that it never, even though it's exponential growth or decay, either way, it never approaches 0, but it never hits 0. Okay, and you think about something that you just keep dividing and dividing and dividing and dividing and dividing, just keeps getting smaller, but it doesn't hit 0. Okay, it just becomes just a smaller decimal that just keeps going on and on and on. Okay, any questions?
Yeah, I got a question. Let's see what it make it. Will it be able to go like this? Like downwards and curve?
This is down and this is like this, but it doesn't go back up.
Yeah, but
It's just a curve that keeps going that way.
that's what I'm saying. Like how I'm showing it, though. Will it be able to go like that?
No, that's not an exponential function. Okay. All right. So what type of sequence are these? Let's go back to linear equations or functions. Linear equations or functions have an arithmetic sequence. They're all arithmetic sequences. You add or subtract to get to the next number in a linear function, the same as an arithmetic sequence. On page 14 in our interactive notebook from last quarter, You can go back and look at the notes on 13 and 14 on how to do arithmetic sequences. Does anybody remember the formula A sub n for arithmetic sequences?
Is it A and parentheses?
A sub n is equal to A sub 1
Parentheses?
Minus n minus 1 in parentheses.
the n minus 1, but what's the operation that goes here?
Multiplication.
No, addition.
Addition. It's plus parentheses what?
Minus 1.
N minus 1 parentheses
D.
times d. And what did the A sub 1 represent in the list? It's the first number, not the zero number. That's A sub 0. It's the first number. So A sub 1 is the first number in the list. What does the n represent? That you're trying to find, the term that you're trying to find. Good. And then what's the d? The common difference. It's like the slope. Okay. All right. So exponential functions are geometric sequences because you're multiplying to get to the next number. Okay. Even if it looks as though it's being divided, you always write it in terms of multiplication. So if you're dividing by 2, that means you're going to say you're multiplying by what? By 1/2. Okay. All right. So this is the one we didn't do. This is A sub n for geometric sequence is equal to A sub 1, the first number in the list. They mean the same thing, A sub 1, times this time is your R. What do you think the R is going to represent? The common ratio, good, to the n minus 1 power. This time, n minus 1 is an exponent because this is an exponential function. You see here where you are subtracting, you see right here where it's being added. This is linear. This is exponential. Any questions about that? Y'all okay? Okay. So now we're going to look at what the tables look like. Does everybody have this copy before I move to tables? Okay, so let's look at what the tables look like. We're going to make a table. We got x values and y values here. We're going to do a linear equation. Let's do a simple linear equation. Let's do y is equal to 2x plus 1. And this is linear. In this linear function or equation, which one of these numbers is slope? The 2 is slope. And which one is the y-intercept? The 1 is the y-intercept. Okay, so now when we create the table, think about what we're doing. Our zero number, our starting number is what? 1. Who said that? Good. It's 1. So what are we doing every single time to get to the next number if it's a linear function? No. When you are with linear functions, you add or subtract to get to the next number. That's why it's an arithmetic sequence. With exponential functions, that's when you multiply to get to the next number. So here, we're adding to get to the next number. So our first number here, we're adding 2. So what's our first number here? This is 3. Do you remember that now? What's our second number? 5. What's our third number? 7. And then let's try to make room for one more. What's our fourth number? 9. Any questions about how we create a linear function? So remember, if I substitute 0 in here, this is going to be 2 times 0, which is 0, plus 1 is going to give me 1. If I substitute 1 here, that's 2 times 1, which is 2, plus 1 is equal to 3. If I substitute 2 here, that's 2 times 2, which is 4, plus 1 gives me 5. If I substitute 3 here, this is 2 times 3, which gives me 6, plus 1 gives me 7. If I substitute 4 here, that's 2 times 4 gives me 8, plus 1 gives me 9. Do you see it? Okay, everybody good? All right. Let's do an exponential function. This is x here, y here. Let's do an easy one. Let's do y is equal to, let's do 3, which is our a starting amount, times 2 to the x power. So again, our starting amount, our a is 3. What's our b, or our common ratio here? 2. Okay, so think about it. Our zero number, what's our starting number? It's 3. Remember I told y'all that? A is your starting amount. That's 3. What am I doing to get to the next number? I'm multiplying by what number? Say again, I'm sorry. 2, yeah. So your first number is going to be what? 6. 3 times 2 is 6. What's our second number? 12. How do we get 12? 6 times 2. Good. What's the third number? 24. How do we get 24? 12 times 2, the common ratio. What about the fourth number? 48. How do we get 48? 24 times 2. Any questions about exponential? What's the difference between them? What's the difference between these? The tables. Go ahead. One's multiplying, one's adding. Which one are we multiplying? Go ahead. Yeah. And which one are we adding? Very good. Okay, which is a linear function. Arithmetic sequences are linear. Exponential functions are geometric. Yes.
Where would you plug in the number that you're trying to multiply?
X. So this is 0, right? So 2 to the 0 power. Anything raised to the 0 power is what? It's 1. Anything raised to the 0 power is 1. So 1 times 3 is what? It's 3 right here. Then plug in 1. What's 2 to the 1 power? 2. What's 2 times 3? This is 6. Then let's plug in 2. What's 2 to the second power? 4. What's 4 times 3? 12. Let's do 3. What's 2 to the third power? 2 to the third power. Somebody said it. 8. What's 8 times 3? 24. What's 2 to the fourth power? That's 2. 16. So what's 16 times 3? 48. Do you see it? That's why we did laws of exponents first. All right, any questions about this? Explicit formulas are formulas where you are finding the term without using the previous numbers. You can just plug it in and get your final answer. So for a linear equation, that's your slope-intercept form. That's y equals mx plus b. And I'm going to go ahead and put the standard form. I mean, it's not really explicit, but we do need to know it. We never use the standard form to plug anything in, but we just need to know the standard form. The a in your standard form, that first number, if it's in standard form, it cannot be a negative or a fraction, okay? It's not an explicit formula, but we do need to know it. All right, explicit formulas for exponential. The generic standard form for exponential functions, and I'm going to ask you this again, so please try to put this in your long-term memory. Y is equal to a times b to the x power. A is your starting amount. B is your common ratio raised to the x power. Okay? These, the ones that I'm getting ready to tell you, are all new, so please don't write big. I'm getting ready to give you 3 more. These are all new. Please don't panic. Okay? Please don't panic. These are all new, and you'll learn them in time. But we're just going to write them here so you will have them on the front page, okay? So the first one is exponential growth. We're going to abbreviate because exponential is long. The formula, and please don't panic, y is equal to c parentheses 1 plus r to the t power. Okay? That's exponential growth. Exponential decay. Yeah, that's right.
So would you would
1 plus r is in the parentheses. Number 1, which is 100 as a decimal.
so Miss Rice, you would do the 1 plus r, then the exponent, then
To the t power. Yes, you
Yeah.
do what's in the parentheses first. Got it? So then what comes out the parentheses?
the exponent,
Mm-hmm. And then last.
the multiplication.
All right, so now we have exponential decay. Y is equal to, any guesses? C parentheses, what do you think of his decay?
Minus
1 minus r to the t power. That's a good guess. And we got one last one in here. We squeezing in. Is compound interest. And this is dealing with money. So the letters here are a little different. Okay? Only because we're dealing with money when it comes to interest. This is money. We got A, which is still really Y, but that's okay. Which one? Compound. Are you talking to me?
Yeah.
What did you say, baby? Compound interest. A is equal to P, parentheses. This is a 1. This is a plus. R over N. This is R divided by N. Close the parentheses. Then this is the exponent. N T. N times T. The last little block. Recursive formulas is where you have to use the previous number to get to the next number. You use the previous number to get to the next number. Oh, another thing, these are explicit formulas here. This is explicit. I forgot to write that in, y'all. This is an explicit formula. All you got to do is just plug in the numbers. And if you want to find the 10th number, you plug in 10, and it'll tell you what the 10th number is by using order of operations. This is also explicit because if you wanted to find the 5th number, you plug in 5 with all the other numbers to give you the 5th number in the list. So this is explicit as well. Both of these are explicit formulas. Okay. This is explicit for linear. This is explicit for exponential. And again, please, go over this, read over it, okay? That's how when I was first learning this stuff and relearning it a long time ago, I had to just read it over again. You can't just look at it one time and remember it. That's not how it works. Don't do your brain that way, okay? Review. Look over the stuff. All right. With recursive, you got your starting at number. This is your starting amount. You always have your starting at. This is going to be your B. So this will be, if we're using this will be starting at 1. That's your starting amount. And then you write the words next. Your next number is equal to whatever your current number is or your now, plus or minus, and whatever your slope is. So if it's 2, it's going to be plus 2 because you're going to add 2 every single time to get to the next number. This is your next now. For linear, this is just next now for linear. You're adding or subtracting to get to the next number. Add or subtract to get the next number. Okay. Exponential functions, you're going to do starting at, same as over here. You always do your starting at, which is going to be your A. So it could be 3. That's your starting number. Whatever your starting number is. And this time, your next is going to be times. You write this in, next is equal to now times And like for this one, you're multiplying to get to the next number. So this will be times 2 if we're doing this one. So this is your common ratio goes here. Your slope goes here. And your starting amounts, your y-intercepts go here. So for exponential functions, you multiply to get to the next number. Please go over this stuff. It's so important that you go over it. Okay? All right, so now I'm going to ask you some questions. Y'all ready for your questions? All right, let's see. You might have to flip back at this page, but let's see how well you listen. We're going to see. All right, what's the standard form for exponential functions? What's the standard form for exponential functions? Yes. Very good. Good, Manny. Sit up, Caleb. Bless this little heart, Lord. Just touch him. All right. Don't hurt him, Lord. Just touch him. All right, so our y is consistent. It's the total, it's the output, it's your dependent variable, the same as linear functions and any kind of functions. Your y's end up going to be the same. It's your f of x, it's your range, it's all of these things. Those are synonyms for y. Your x is the same in all of the functions as well. It's going to be your input value, same thing you learned in 6th grade, your independent variable, your, what else, Lord? Domain. What did we say for exponential functions? What did we say our A represented? Starting amount. Or initial value, starting amount, y-intercept. All of those words, okay? What did we say the B represented? Oh, Jesus. What does the B represent? Somebody said it. Yes. Common ratio. No, you didn't say that. You be making up. I would have heard it. You're right in front of me. All right, so now we're going to write these in. We wrote them on the first page. Okay. The generic formula for exponential functions is y is equal to a times b to the x power. If it's exponential growth, for exponential growth, and they give you the percent, this is the formula you use. You got y is equal to, sometimes they still use a, but sometimes they'll use the letter c. A and c mean the same thing. C is still going to be the starting amount. It's still the same. Why they use a different letter, I don't know, y'all. Because it's a word problem. Okay? I don't know. I don't have the answer for that. But they are still the starting amount. Your B in exponential growth, your B is now going to be 1 plus R. So your B here, instead of just writing B, they're not going to give you the common ratio. They're going to give you the percent of increase. So instead of using just B, you're going to use 1 plus R. That's the same as B. They are the same. B is equal to 1 plus R. 1 plus R is equal to B. And T, they usually change it to the letter. X is usually, X and T are the same. Why, Miss Reyes, do they use T instead of X? Because T represents time. Your X values for these type of problems are going to be time. Minutes, hours, days, years, months. It's always going to be one of those things. So they just, instead of using X, they just use T. Any questions about that? So this represents the time. This is the final amount, or, the total. And keep it simple for you. This is your starting. This is 100%, but it's written as a decimal. Okay. This is your rate as a percent. Okay. Actually, they write it as a decimal. Okay. So now we're going to write the same thing for exponential decay. I'll give you a second to catch up if you're behind. The generic formula, we said again, is A times B to the X power. For decay, in a lot of these word problems, instead of giving you the common ratio, they're going to tell you the percent decrease. So we use the formula similar to this. We have our starting amount, our A or our C, times, this time B, since it's decay, it's going to be 1 minus R to the T power. So your B for decay is equal to 1 minus R for decay. So again, your C is your starting, your start. Your 1 is 100% as a decimal. Okay. Your R is your rate as a decimal. And your T is time. And then no worries, we will finish the rest tomorrow. Okay? Please make sure that you keep up. Don't lose this, okay? Because it's a lot to start over. Okay? Don't lose it. Please put this in your folder. Do not lose this. Put your calculators back. If you have my glue sticks, please put my glue sticks up.